All right, welcome. We're going to be doing part 2 of this June Regents. For our first question, this is basically finding angles of a parallelogram, and the last time we saw that was in level 5. Level 5 in parallelograms. Dope. All right. Now, to do this problem, you should know the properties of a parallelogram. I've done it before. I'm not going to do it again, but I will tell you, if you want to know those, you can look at 5.1, and that's actually where you learn in that video properties of parallelograms. Okay? That's a good reference. So if you want to study for this test, check out 5.1, and it'll give you all those properties. Now, this question says, explain why angle NLO is 40 degrees. There's a bunch of ways to do this. We'll just do one of those ways. What I would do is this. I would say that angle O is 118 degrees. All right. Now, when you fill in an angle, you always explain why you filled it in. So we would say angle O is equal to 118 degrees. And that's because opposite, and I'd say because opposite angles in a parallelogram are congruent. All right. Now, once I have that done, I'm going to then say, well, this. So I know that angle NLO is the one we're looking for, and that's also 40 degrees. And for that one, I'm using the triangle sum theorem, right? I'm just doing 180 minus 118 minus 22, and that gives you 40 degrees. So for that part of it, now that I've figured out y and L, I'll say angle NLO is equal to 40 degrees because of the triangle sum theorem. And that is pretty much all you need to do to explain why angle NLO is 40 degrees. We said opposite angles are congruent, so we know this is 118, then we use the triangle sum theorem to find out that that angle is 40. Done and done. Easy points. Now for the second one, this is one of my favorites, all right? Now I'm going to zoom out a little here. I'm going to zoom on out. We can look at the whole playing field here. Now this one says the coordinates of endpoints AB are A, -6, -5, and B, 4, 0. Point P is on AB. Determine and state the coordinates of point P, that AP to PB is 2 to 3. All right, now just to tell you where this is from level 8. And in level 8, we learned about applications of coordinate geometry. And if you really want to reference this, you could do 8.5, and that's from partitioning line segments. All right, now in partitioning line segments, this is how it's going to go down. So first you start with just plotting your points. So I think we know how to do that. We have, let's zoom out a little bit more, -6, -5. So that's -6, -5. And then that's our A. And B is at 4, 0. Easy. That's our B. We draw the line. Now the next step you might remember is to add the ratio. And that's because we're trying to cut this into 2 parts to 3 parts. That means totally we're going to be cutting this into 5 equal parts. That's the goal of this. So now, once we know the ratio, we're cutting into 5 parts, we're going to count how long this is horizontally and vertically. So horizontally, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 across, and then 1, 2, 3, 4, 5, 5 up. All right, so we have 10 across and 5 up. All right, now we're going to cut those both into 5 equal parts because that's what our ratio is. So we're going to do 10 divided by 5, and that gives us 2, and 5 divided by 5, which is 1. So that means every time I go to the right 2 and up 1, I'm cutting this into an equal part. So now all we have to do is start cutting. So I go over 2, up 1, over 2, up 1, over 2, up 1, and over 2, up 1. And now you'll see that we've cut this into 5 equal parts. Now all we have to do now is figure out where the ratio is 2 to 3. So if we go count 2 parts, which is right here, that's 2 parts, that's 3 parts. So my point is right here. And so point P would be at -2, -3. Done and done. Okay, next one. Ooh, okay, we got a little trig going on here. So this one says find the angle of elevation, which is right here. All right, angle of elevation is to the ground, looking up. So our x is this angle right here, x degrees. Now we saw this in level 6, where we learned about trigonometry. And if you really want to reference this where we find a missing angle, look at lesson 6.3, and that's finding missing angles. Okay, and that should be a good refresher for you. So to do this lesson, remember, there's two things we always do. We're going to label our sides and write SOHCAHTOA. So let's label our sides across from the angle, that's our O. Across from our 90 is our hypotenuse. We got O and H, so now let's look at SOHCAHTOA. And if you look at this, looks like we have sine here, O and H. So let's write it out. So we say the sine of our angle, which is x, it's our unknown, is equal to opposite over hypotenuse. Now to solve this one, to get x by itself, you might remember this, but we use the inverse sine. So we're going to inverse sine both sides. And if you're ever looking for an angle, you're going to be using the inverse sine. Those cancel, and we get x is equal to sine -1 of 4.5 over 11.75. Now this you just put in your calculator, and you should get x is equal to about 22.5. Now if you look at the question, it says do this to the nearest degree, so we're going to round this up, and we're going to say that the angle of elevation, the angle of elevation is 23 degrees, right? We're rounding this up to the nearest degree. And that's it. Now remember, these are 2-point questions, so if you don't round correctly, you actually lose a full point, and you did all this great math work. So make sure you round correctly. All right, number 29. In the diagram below in circle O, the area of the shaded sector is AOC is 12 pi. And the length of OA is 6. Determine and state the measure of AOC. So the angle is our x in this point, and we know the shaded sector is 12 pi. Now this is from level 9, where we learned about circles. And if you really wanted to review this exact topic, all you'd have to do is go to 9.4, area of sectors, and as an add bonus, you have arc length and arc length. Now this is the area of a sector, so obviously we're going to write down that formula. So the area of a sector is equal to theta over 360 times pi r squared. And remember, this is just the area formula right here, and this is just the proportion of the angle to the total, which is 360. So it's the same formula, pi r squared, with this added to it, theta over 360. That's just our proportion. Now we're just going to plug in what we know in this question, and what they've given us is the area. So we can plug the area directly in, and we get 12 pi is equal to, now theta is our missing angle, so that's what we're looking for, so we'll put x there, x degrees, times pi times 6 squared. That's our radius. So we plugged in our given information, and now we just got to solve this guy. So to do so, let's start off with this. We're going to cancel out our pi's. There's a pi on both sides, so you can divide both sides by pi, it goes away. Then we're going to multiply both sides by 360. All right, multiply both sides by 360, cancels out on the left side of the equation, and on the right side of the equation, we just put that in our calculator, and we get 4,320 is equal to, well, all we have left is 6 squared times x, which is 36x. Divide both sides by 36, and we get x, 120 is equal to x. Now that's good, but we want to find out our final answer, so angle AOC is equal to 120 degrees. And remember to put your degrees in all your right measurements, because, like I said, you lose points even if you forget your measurement. All right, now this one should be a piece of cake. After a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. Explain why triangle ABC is congruent to A prime, C, B prime, C prime. Well, let's just draw a quick little picture here. So we have ABC, it's reflected over a line, and we get A prime would be here, B prime would end up here, and C prime here. Now, how do I know these two triangles are congruent? Well, we should know this straight up. This is from level 1, transformations. And you learned about this in lesson 1.2 directly. And that the name of that is transformations. And you learned, using the properties of rigid motions, we would state this. A reflection is a rigid motion, and rigid motions preserve both angle measures and side lengths. So since angle measures and side lengths are preserved, we know under this transformation, well, nothing changed. It stayed exactly the same. So AB, so we'd say therefore, triangle ABC is congruent to triangle A prime, B prime, C prime. That's it. So whenever it says using, you should use the properties of rigid motions. You know reflection is a rigid motion, so that's it. That's it. We know rigid motions preserve side lengths and angle measures. They're going to be congruent. All right, and our final one for this video, a flagpole casts a shadow of 16.6 meters long. Tim stands at a distance of 12.5 meters from the base of the flagpole, such that Tim's shadow meets the end of the flagpole shadow. If Tim is 1.65 meters tall, determine and state the height of flagpole to the nearest tenth of a meter. Well, this is all about just drawing a really good picture. So we got a flagpole, right? And it has a shadow which goes across the ground of 16.6 meters. All right. Now, Tim stands at a distance of 12.45 meters from the base of the flagpole. All right, so he's 12.5 meters, so that'd be right here from the base of the flagpole. This is our guide, Tim. All right. And we know that Tim's shadow also meets the end of the flagpole shadow, so both of their shadows meet here. So we can just draw a nice little double triangle like this. Tim, we also know, is 1.65 meters tall. So we want to find the height of the flagpole, so we'll put an X here. Now, what we're going to do is this. We're going to draw two triangles, because these are similar triangles. We know they're similar because, well, a flagpole is perpendicular to a ground. Tim is perpendicular to the ground, and we got the reflexive property right here. So we have angle-angle similarity. So this is level 3, similar triangles. All right. Now, let's actually just write this on out. So what we're going to say is this. We got a big triangle like so. That's with the flagpole. So we have X, and we have our whole shadow, which is 16.60. Then you have your smaller triangle. And check this out. Timmy's 1.65, but what's this length right here? Well, that's not known. That's actually not known. What we have to do is subtract 12.45 from the total length, which is 16.6. And what you do is you get 4.15. And that's what goes here. And that's the trick to this question, all right? If you didn't do that, you'll probably get 2.2, which is incorrect. So now we'll just set up our ratio. X is to 1.65 as 16.6. 0 is to 4.15. All right, nice and easy. Cross multiply this. 4.15x is equal to, well, I got to put this in the calculator myself. Let's put it in. 16.6 times 1.65, that's 27.39. That doesn't make sense. 16.6 times 1.65. 16.6 times 1.65. Oh, okay. And then we just divide by 4.15, and we get x is equal to 6.6. Now, we're going to actually answer this question correctly. So the height of the flagpole is 6.6 meters tall. Notice the units are there, and that is our answer. Circled and complete. All right, that's it for part 2 questions. Next video will be part 3s.